All right, now, to solve this model, what we want to do, suppose we want to solve for the equilibrium value of y. Then we just use the method of substitution. Right now, we have two equations, and notice y appears in both of them. So what we want to do is take that second equation for the consumption function and get rid of c. And then you'll just have one equation in one unknown, y. And then you can solve for y. That's the process, solving by process of elimination of variables. Okay, so let's do that. If we just take that first equation and now substitute for c, we get y equals, and let me put parentheses around this c term, a plus by plus I plus g. Okay. Now, notice there's only one endogenous variable in this equation, y. So the way we solve it is we get all the y terms over on the left-hand side, and then we solve for y. Okay. Subtract by from both sides, we get y minus by equals a. Let me drop the parentheses because I don't really need them. A plus I plus g. Now factor out y on the left-hand side, and we get y times 1 minus b equals a plus I plus g. And now the last step is to divide both sides of this equation by 1 minus b, and then we're just left with y on the left-hand side. So doing that, we get y star, our equilibrium value of y, is just a plus I plus g divided by 1 minus b. Notice on the right-hand side, all we have are parameters and exogenous variables. That's always what your goal is, to solve for the equilibrium value. You want to get an expression for that variable with nothing but parameters and exogenous variables on the right-hand side. The idea is, if you know the values of these parameters and exogenous variables, then you just plug into this formula and out pops your equilibrium value of y.